Intermediate value theorem. This is a really important theorem in calculus. We make a real big deal about it. It's a very helpful, useful theorem for us. Here, it's a nice thing to know about polynomial functions because they're nice and connected. They're smooth. They're like roller coasters. This theorem works. It says if I have a polynomial function with real coefficients, p of a and p of b are of opposite signs. Okay, so these represent y values because it's a function value, and this first one is the y value associated with the x equaling a. This one is the y value associated with the x equaling b. And if those two y values are of opposite signs, it tells me I have to have a 0 between that a and b. Okay, so graphically, visually, this is what's going on. We've got our two x values, a and b. Okay, and then the y value associated with a, I'm going to say it's a positive value. I don't know where, but it's somewhere on the positive side. So that means my ordered pair for my graph would be here. The x and the y match together. The b is here, and the p of b is going to have to be negative according to this theorem. Then my function is going to have a point on the graph right here where I match up that x and y. Well, because the polynomial functions are nice and smooth, these have to be connected, which means at some point between a and b, we have to cross the x-axis. That means we have an x-intercept or a 0. Okay, now this is really, really important, this next part that I'm going to tell you. It says, if I can scroll down, that the intermediate value theorem can be used to verify zeros but not exclude them. Okay, so what happens if my two function values, f of a and f of b, or p of a and p of b, are both positive? Does that mean that there's not a 0? No, it means I can't say anything for sure, because what could happen, I could be here, cross through, and come right back up, cross again, and still end up being positive by the time I get to b. But we crossed actually twice. Okay, so it only verifies, doesn't exclude. Let's take a look at an example. Can we use this intermediate value theorem to determine if we have a 0 between the given a and b? So here's our function f of x, and then the a is -5 and b is -4. So how are we going to figure out if we have a 0? Well, we plug the -5 in and work it out. When I plugged in -5, worked it out carefully in the calculator, I got -18. When I took the -4 and I plugged that into my function, worked it out, again, just use the calculator, I got a 7. I note that these are opposite signs, so somewhere between that -5 and the -4, my graph crosses the x-axis. I have a 0. Right? The next example we've got, this is a x to the 4th minus 2x squared minus 6, and this time my a is 2 and my b is 3. So if I want to know if there's a 0 between 2 and 3, I plug the 2 in and see what happens. I got 2. I plug the b in, the 3, see what happens. I got 57. Okay, well this time they're the same sign. Does that mean there's not a 0? Not necessarily. I can't really say anything. At this point, I would say the test is inconclusive.